In today's video, I will solve a problem based on moment area method for a simply supported beam. So, simply supported beam, and in this question we have to find the slope. Find the slope, okay, by using moment area method. So, this is the question for a simply supported beam. Here, one load is acting. The load is 30 kilonewton and the total length of this beam is 6 meter, and let it be A and B, and from this point to the loading the distance is 2 meter, and from this to that side is 4 meter. So this is the question, and here we have to find the slope. Okay, now the first and foremost things what we have to do in this method is to draw the bending moment diagram. Okay, so to find the bending moment diagram, here see, in this question the load is acting at this point, so the bending moment will be maximum at this point. So to find the value of the maximum bending moment, we have to know the RB value, reaction at B. So first we'll find the RB value. So to find the RB value, we have to take summation of all the moment about A is equal to 0. Now it will be RV, summation of A, that means all the force will go towards A, and we have already discussed those things in my strength of material chapter. So you can go through and check the things how to find the RA and RB value, that is reaction at A and reaction at B, and how to find the moment also here. Now summation of all the moment about A is equal to 0, that means all the force will go towards A. Okay, so now this force RB, let it be RB. Okay, so RB, to reach at this point, how much distance it's cover? Total distance is 6. RB into 6. Okay, minus, see, upward force will take it as positive and downward force will take as negative. Okay, so it's a upward force, right? So it will be a positive RB into 6. And now next, this is load is acting downward, so it will be minus 30, and this loads cover 2 meter distance to reach at this point, that is into 2, okay, is equal to 0. Now we have to simplify it. 6 RB minus 30 into 2 is 60 is equal to 0. So 6 RB, and if we shift this value that side, then it will be a positive, right? So it will be positive 60. Now we can easily get the RB value from here, that is 60 divided by 6, and it will be 10. Okay, so here RB value is 10 kilonewton. So now we have this value with us, RB value. Now we have to find the moment. So bending moment at C, here let it be C point. So here up to here we have to find the bending moment, so it will be RB into 4, RB into 4, RB into 4, right, to reach this distance is equal to 0. So what is the value of RB? RB is 10. 10 into 4 is equal to 40 kilonewton meter. So bending moment at C is equal to 40 kilonewton meter. So now we have a value for maximum bending moment, that is nothing but 40. So now we can draw the bending moment diagram. Okay, so it's a positive, right? So now just draw the imaginary line, C point, A, B, and it was C, right? So maximum bending will occur at C point, as it is a point load, so the line will be straight. Okay, like this. So here it's a 40 kilonewton meter. So it's nothing but bending moment diagram. Now we have to draw the M by EI diagram. So next step is to draw the M by EI diagram. So M by EI diagram will be same as bending moment diagram. Just we have to divide this by EI. EI is nothing but a constant value. So it will be same A, B and C. Here 40 divided by EI. Okay, so it's a M by EI diagram. Now we have to draw the elastic curve. Okay, so to draw the elastic curve, this is A, B, and elastic curve will be due to this loading. How our beams will looks like, it will bend like this, right? So now what we have to do here is we have to draw a tangent line from B to this point. Let us trace the line here to here, and from A to up to this line. Okay, so now it's a tangent. So now let this distance from here to here it be TAB, and from here to here distance let it be TBA. Okay, so now here I'll write down what is TAB and TBA. So here TAB is equal to vertical distance at A and the tangent drawn at B. Okay, same like TBA is the vertical distance at B and the tangent drawn at A. Okay, now we have to find this distance as well as this distance to get the value for theta A and theta B. And here theta A is the slope at A and theta B is the slope at B. Okay, so now in this question what it says that we have to determine the slope. So now what we have to do is first we'll find the TAB value, this value. Okay, so to get the TAB value is equal to, now see, okay, before starting with this I'll draw one. Okay, I'll draw this M by EI diagram again. So it was like this, right? It was like this, and this is C point, this is A and B. So we'll draw a imaginary line here. Now to get the area, okay, we'll separate this part, we'll find this area separately as well as this area separately. So to find the area, this is a right angle triangle. So the formula for finding the area is half into base into height. Okay, so here half into what is the base here? This was it was 4 and 2, I guess. Yes, okay, this is 4 meter and this is 2 meter. So base is, for this one base is 4 and the height is, this is the height, that is 40, and this one would get cancelled to the 80 meter, right? So now here it's 80 meter, this area. Again we have to get the area for this part, right? So now this one was 4 meter, this is 40. Okay, now again the area, this is 2 meter and the height is same, that is 40. So area is equal to half into base into height. is equal to half into base is 2 into height is 40. So this one and this one will get cancelled and we'll get the value around 40 meter. So this area is 40 meter. So now according to this bending moment diagram, we'll draw a free body diagram here. Okay, so free body diagram. A, B and C. Now here 40, it's a positive, right? So it will act downward. It's a 40, sorry, it's a 40, and here it will be 80, right? 80 meter. Now we have to determine the distance. Okay, and we know that to determine the distance, what we know is here CG. CG is nothing but the center of gravity. Okay, so center of gravity, if we find from this side, that means it's a B, right? It's a C. So the formula will be 2/3 of L, and here from this to this end it will be 1/3 of L. So here 2/3 of L is 4. So the value will come around 2.67, and for this one 1/3 of 4, then the value will come around 1.32. okay, so this distance is 2.67 and this distance is 1.32. Same like this, we have to determine this distance also. So here CG will form at the center, and here same like this one, 2/3 of L, and this will be 1/3 of L. So now 2/3 of 2 will be 1.33, and this one will be 0.67. okay, so this is 0.67 and this is 1.33. okay, these are the distance, and this is nothing but the free body diagram. Now we have all the values with us. Now we can easily find. So TAB value. Okay, TAB is nothing but a vertical distance at A and the tangent drawn at B. This is the distance, and we have to find the value for this. To get the value, what we have to do is, see, to reach here, this load, that is 40 into the distance 1.33 plus this 80, right? 80 into, and this load have to reach this side along A, and how much distance it will cover, that is up to here, it's 3.33 into 3.33, then we'll get the value around 319.6. okay, so now see, just we have a TAB value from here to here, right? That is 319.6, and this value is total length is 6 meter. Now we know that, right? We know that tan theta is equal to perpendicular by base, right? So here perpendicular, this is the perpendicular distance and this is the base, right? So base is 6 and perpendicular is 319.6. so now just we need to put the value here. Perpendicular is 319.6 divided by base was 6, so it will be theta will be here, and tan inverse of 319.6 divided by 6, then we'll get the value around 53.26. so this is the value for theta A. So now theta A is equal to slope at A is equal to 53.26. so theta A value is 53.26. so this is the value for slope at A. Now again we have to find the value for theta B, and theta B is nothing but slope at B. So again we have to draw the same, that is TBA. TBA is equal to, now just see the free body diagram here, all the force will go this side, so it will be 80 into this distance, right? So write 80 into 2.67 plus, again see 40 into this distance, right? This distance is 4 point, again from here to here is 4.67, so 40 into 4.67. now we'll get the value around 400.4. now again we have to do the same thing, that is tan theta is equal to perpendicular by base. So tan theta is equal to perpendicular distance is what? Here this is the perpendicular 400.1, right? So this value is 400.4. so this is the perpendicular distance from this side, and this is the base will be same for the both. So now it's 400.4 divided by base is 6, so we'll keep the theta here, and then this 10 will be the inverse of 400.4 divided by 6. So now we'll get the value for theta B is 66.73 degree. So now this is the value for theta B is equal to 66.73. okay, so our motive was to find the slope in this case. Okay, thank you.